Welcome to Lesson 5.4, Quadratic Relations in Factored Form. If you did the activity, the matching activity, you should have noticed a couple of things. Firstly, that when the equation of the parabola is in factored form, it tells us something about the parabola graphically. So when this is what we call factored form right here. And so it is expressed as things being multiplied by each other. Remember, we talked about earlier what factoring means. Factoring means to express something as two other things being multiplied. So for instance, I'll use the same example that I used before. The number 10 factored would equal 5 times 2. So it's all multiplication. So this A is being multiplied by this x minus r and this x minus s. Algebraically, there's usually some addition and subtraction going on in factoring because there's generally addition and subtraction going on in the original question. So you may have noticed that the numbers in the brackets actually have the opposite sign of what the x-intercept turns out to be. So for example, if the equation of the parabola was, say, 2 bracket x minus 5, x plus 3, it doesn't turn out that the x-intercepts are -5 and +3. It actually turns out that the x-intercepts are +5 and -3. So they're the opposite sign of what you see inside the bracket. That's why in the general form we have negatives. It's x minus r and x minus s because we want the opposite. That minus just means opposite. So why does that happen? Well, it's got everything to do with x-intercepts and what we do when we're trying to find the x-intercept. If you remember with linear relations, to find the x-intercept, we let y equal 0. So we do the same thing no matter what the equation is of whatever the graph looks like. You'll learn in grade 11 and in grade 12. When you try to find the x-intercepts, you always want y to equal 0. And then you got to figure out a way to solve the problem. Linear is easy. You let y equal 0 and then you just simply solve for x. Quadratics and other relations aren't so easy to figure out, so we have to come up with other ways. So if I take this equation here and I let y equal 0, so 0 equals 2x minus 5x plus 3. We need this times this times this, so 2 times x minus 5 times x plus 3 to equal 0. Fundamental theorem of mathematics. If A times B equals 0, then either A has to equal 0 or B has to equal 0. The only way you can have two things multiplied together to equal 0 is if one of those two things is 0. You can try and defy me. Like, try and find two numbers that aren't equal to 0, and when you multiply them together, you get 0. You can't. So that means that either 2 has to equal 0, which it does not, or x minus 5 has to equal 0, so x minus 5 has to equal 0, or x plus 3 has to equal 0. So when you solve x minus 5 equals 0, you move the 5 over to the other side. It becomes a positive, and there you go. That's why that's a +5 and not a -5 as the x-intercept. So when x equals 5 here, that corresponds to the x-intercept 5, 0. And then similarly for x plus 3, when you bring the 3 over to the other side to solve for the x would have to equal -3. So that corresponds to the x-intercept -3, 0. So the x-intercepts are also called the zeros. And the reason is because we let y equals 0 to find them. They are when the function or when the relation equals 0, that's what those two values are called. So they're on a graph, they're called the x-intercepts. And then in kind of like just a generic equation like this one, which we're going to be solving later on in many different ways, but this is one way of solving what we call a quadratic equation. It's different than a linear equation. It gets factored, and then we use this fundamental theorem of mathematics right here. If a times b equals 0, then a equals 0 or b equals 0 to figure out what the zeros are. Okay, now you should also have learned by doing that matching activity that there are different forms of the equation. So you have the equation in factored form, while you can expand it, and we've already talked about how to expand. And then you get the equation in what's called standard form. Okay, so this one up here, this one is called factored form because it's everything, it's this times something. It's all multiplication. But standard form is not all multiplication. There's all this addition going on. We're not taking ax squared and multiplying it by bx and multiplying it by c. We're adding them. So this is called standard form. I'm just going to go in a different color here. Let's go with pink. Okay, so this is standard form. And you should have learned by doing that matching activity that the c value in standard form is equal to the y-intercept. And why does that happen? Well, let's go back to linear relations. If you want to know where the y-intercept is, what do? You let x equal 0. So if I take the equation y equals ax squared plus bx plus c, and I let x equal 0, I get y equals a times 0 squared plus b times 0 plus c, and that just turns out to be c. So that corresponds to the point 0c on the graph, which is the y-intercept. So there's a reason why we have different letters to represent different things. So this C here is not the same as S or R. I mean, sometimes it can be, well, actually only if it's 0. But they're not the same. So we use different parameters. Those numbers are called parameters. Y and X are called variables because those are the two variables that we're looking at the relationship between. On a graph, we've got the x-axis and the y-axis. So those are the variables. But the A, the B, and the C, those are the parameters that make the parabola look like it needs to look like. Okay, so those are called parameters. All right, so if I take this example from up here and I bring it down here and I expand it, so y equals 2x minus 5x plus 3. So then when I expand these, I expand the bracket parts first and then I multiply by the coefficient. That's just how it makes more sense in my brain. What you don't do, you do not multiply the 2 into this bracket and the 2 into that bracket. No, no, no. That would be like taking y equals 2 times 3 times 4, multiplying 2 times 3, getting 6, multiplying 2 times 4, getting 8, and telling me that the answer is 48, when we already know 2 times 3 is 6, times 4 is 24. So if you recall, the distributive property, it does not work over multiplication. You can't multiply 4 things together or 3 things together and multiply 1 times the other 2 things more than once. You just can't do that. Okay, so what I do to make sure that I don't do that, not that I would, but what I do is let me just erase this little arrow thing here because I don't want you to do that. You can, and there's nothing wrong with this, you can multiply the 2 into this first bracket, and that would be 2x minus 10. You just got to make sure you put brackets around that, because that whole thing needs to be multiplied by the second bracket. So what I do is this. I don't multiply the 2 through until the end. So oh, here, let me just erase that. Everything keeps disappearing on me. Okay, what I do is I expand this part here by doing x times x. So I've got the 2 out in front and a bracket. X times x is x squared. X times 3, we'll do that next, which is a 3x. And then minus 5 times x is a minus 5x. And then a minus 5 times 3 is a minus 15. I simplify what's inside the bracket, so that's x squared minus 2x minus 15. And then I expand this, I just double everything. So 2x squared minus 4x minus 30. So this number here would be the y-intercept, negative 30. So that corresponds to, oh, sorry, nope, wrong way. That corresponds to the point 0, negative 30. It's the y-intercept. Okay, the other way to find the y-intercept is like we always do. If we have the equation in this factored form up here, then the other way to find the y-intercept is to simply let x equal 0. So you're going to get y equals 2 times 0 minus 5 times 0 plus 3 equals 2 times negative 5 times 3. 2 times negative 5 is negative 10 times 3 is negative 30. But that won't tell you what the b value is. So I want you to take a look at what happens here. The a value in my original equation was 2. The a value is still 2. That's why in the generic forms we have an a here and we have an a here. Those two a's are going to be the same number regardless of what form we're looking at. There is a third form of the equation of a quadratic relation that we're going to be talking about later. We're just going to worry about these two forms right now. If you only find the y-intercept this way, that's not going to help you figure out what the entire equation is. I should make this y equals. That's not, it's not going to tell you what the entire equation is. You would know what the a is because you got the a in the factored form. You can do this to find out what the c is, what this c value here is, but that doesn't help you figure out what the b value is, so you're going to have to go through the algebra of expanding and simplifying. Okay? I think what I'm going to do is that's a lot of information. I'm going to stop there, but this is what you should have learned through that matching activity. Maybe not the names of everything, but we've talked about expanding. But what you should have noticed was that the x-intercepts of the graph of the parabola relate to factored form, relate to this form here. And that the y-intercept of the parabola relates to this form here. Okay? And you have to be in the two different forms to be able to tell what those two different pieces of information are. All right, so that's a bit of a summary of that part. So I'm going to stop there and then I'm going to move on with the lesson in the next video.